So let's talk about our energy future. What if I told you that one of the most powerful new sources of energy isn't some giant new facility? What if it's already here, hidden in plain sight, scattered across millions of our own homes and businesses? We're talking about a power plant that's already been built. It's just waiting for us to flip the switch. See, this new kind of power plant isn't made of concrete and steel. It's called a virtual power plant, or a VPP for short. And really, it's a smart network. Just imagine thousands, even millions, of smart thermostats, home batteries, and electric vehicles, all orchestrated by incredibly intelligent software to work together as one single massive power source for the entire grid. And this isn't some sci-fi concept from the future. Nope. Right now, a company called EnergyHub already manages a virtual power plant with a capacity of 3.5 gigawatts. Now, what does that number even mean? Well, that's basically the same output as 2 or 3 full-scale nuclear power plants. It is happening right now, and it is growing incredibly fast. The scale here is obviously impressive, but it brings up an even more interesting question. We know a VPP can act like a traditional power plant, but could it actually become something better? Could this smart, decentralized network become even more powerful, more useful than the big, clunky power plants we've relied on for the last century? That's the journey we're going to explore. To figure that out, we first need a way to measure just how sophisticated a VPP is. And luckily, the industry has come up with this brilliant framework called the Huel's test. And the best way to think about it is like the famous Turing test for artificial intelligence, but for a power grid. The analogy is actually perfect. The Turing test, right? It asks, can a computer fool you into thinking it's a human? Well, the Huel's test asks, can a network of thousands of little devices, thermostats, batteries, you name it, convince a grid operator that it's just one big, predictable power plant? Can it behave so perfectly that the person managing the grid can't even tell the difference? So to pass this test, a VPP has to deliver on 3 absolutely crucial things. First up is visibility. The grid operator needs to be able to see it in real time and know exactly how much power it has. Second, schedulability. They have to be able to tell it precisely when to turn on, how fast to ramp up, and when to power down. And finally, availability. This one's simple. It just has to work when they call on it. No excuses. But here's the thing. Getting a VPP to that point isn't just an on or off switch. It's a journey. You know how autonomous cars have different levels of capability? You start with basic cruise control and work your way up to fully self-driving. Well, VPPs have their own maturity model, and it maps out their journey from a pretty simple tool to a truly intelligent grid asset. So let's walk through this evolution. It all starts at level 0, which they jokingly call press and pray. You send out a one-way signal and just hope for the best. At level 1, you start getting some data flowing back. At level 2, where most VPPs are today, you use that data to create a nice, smooth, predictable shape of energy reduction. But the real leap is to level 3. That's when it's fully automated and can finally pass that Huel's test. And then there's level 4. This is the holy grail, a grid-adapted VPP that does more than a traditional plant ever could. And this is the ultimate goal. A level 4 VPP isn't just a substitute for a power plant, it's a total upgrade. It becomes what you might call a super plant, capable of things a traditional, centralized plant could only dream of. And really, the logic here is just undeniable. As EnergyHub CEO Seth Frader-Thompson puts it, why wouldn't you want this? It's cheaper, it's greener, it's built around the customer, and you can get it up and running in a tiny fraction of the time it takes to build new physical infrastructure. It's a win-win-win-win. And as these VPPs get smarter, the value they provide just keeps stacking up. A basic VPP, right? It saves money because you don't have to fire up an expensive power plant. But as they get more advanced, they can do more, like preventing costly upgrades to your local power lines. And at the highest levels, they can provide what are called ancillary services. Think of them as shock absorbers for the grid, keeping everything stable, balanced, and resilient. You know, this point about avoided distribution capacity might sound technical, but it is a huge deal. A massive chunk of our electricity bills goes toward building and upgrading the local grid just to handle a few hours of super high demand each year. It's like building a 20-lane highway for a traffic jam that only happens on Labor Day weekend. By using a VPP to flatten those peaks, we can avoid building all that stuff that just sits there unused 99% of the time. And that keeps electricity more affordable for all of us. Okay, so if this is so great, what's stopping us? How do we get there? Well, unlocking the full potential of these VPPs really requires a clear roadmap, a coordinated push from the tech companies, from the utility industry, and from the regulators. Getting all the way to level 4 is definitely a team sport.
On the tech side, we need ultra-fast data. We're talking updates every 2 to 6 seconds to give grid operators a true real-time picture. The industry as a whole has to clean up a bunch of old, clunky code, what some call software craft, that slows everything down. And finally, utilities have to build secure, scalable ways to bring all this new data right into the heart of their operation.
And of course, regulators have a massive role to play here, and the path forward for them is surprisingly straightforward. First, give utilities clear goals, but don't try to micromanage them with overly complex rules. Second, encourage pilot programs to test out these advanced VPP skills. And maybe most important of all, provide some long-term stability, things like multi-year revenue guarantees. That gives the whole industry the confidence it needs to invest and innovate for the long haul. So, the next time you think about where our power comes from, maybe think about this. What if the next great power plant we build isn't a massive centralized building at all? What if it's a network? A network of our own homes, our businesses, all working together in concert. What if the next power plant is us?